Welcome to the introduction of data warehouses. In this session, we will explore traditional data warehousing concepts and their role in modern big data architecture. So, what exactly is a data warehouse? A data warehouse is a centralized repository that stores integrated data from multiple sources. It is optimized for query and analysis rather than transaction processing. Think of it as a single source of truth for making informed business decisions. Data warehouses have key characteristics. They are subject-oriented, meaning data is categorized by business subject rather than application. They are integrated, meaning data from various sources is combined into a unified format. They are non-volatile, meaning data is not altered or removed once it is in the warehouse. And they are time-variant, meaning data is recorded with a specific time period, providing a historical perspective. Here's a look at a traditional data warehouse architecture. At the beginning, we have different data sources. These include online transaction processing systems or OLTP systems, legacy systems, external data, and regular files and documents. All of this data is then moved to a staging area. In the staging area, extraction, cleaning, transformation, and validation processes take place. Finally, the refined data is loaded into the data warehouse, which consists of fact tables, dimension tables, data marts, and metadata. The ETL process is made up of 3 steps: extract, transform, and load. First, the extract step involves retrieving data from various source systems, which may include databases, files, and applications. Next is the transform step. In this step, data is cleaned, validated, and converted into the required format for analysis and reporting. The final step is load. In the load step, the process data is inserted into the data warehouse for querying and analysis. Data warehouse schema design involves 2 popular schemas. The first is the star schema. It has a simple structure and offers fast query performance, but uses denormalized dimensions. The second one is the Snowflake schema. The Snowflake schema uses normalized dimensions, reducing data redundancy, but it results in more complex queries. A star schema consists of 1 or more dimension tables joined to a central fact table. A Snowflake schema is a variation of the star schema, where dimension tables are normalized into multiple related tables. It's important to understand the differences between online transaction processing, or OLTP, and online analytical processing, or OLAP systems. OLTP systems are designed for transaction processing, focusing on current operational data in simple, fast queries. They require response times in milliseconds and handle moderate data volumes with many concurrent users, primarily performing insert, update, and delete operations. OLTP systems use a normalized schema design. On the other hand, OLAP systems are designed for analytical processing, focusing on historical and aggregated data with complex analytical queries. These systems may have response times ranging from seconds to minutes and handle very large data volumes with fewer analytical users, primarily performing select and aggregate operations. OLAP systems use a denormalized schema design. Data warehouses have evolved significantly and play a crucial role in modern big data architecture. Originally, they handled traditional structured data. Over time, they have adapted to multi-source integration, cloud-based solutions, real-time processing, and the integration of artificial intelligence and machine learning. In today's landscape, data warehouses integrate with data lakes for structured analytics, serve as a central hub for business intelligence, ensure data governance, and operate within hybrid architectures as part of modern data mesh and fabric solutions. Here are the key takeaways from our discussion. Data warehouses provide a centralized and integrated view of organizational data. ETL processes ensure data quality and consistency. Star and Snowflake schemas optimize analytical queries. OLAP systems serve different purposes than OLTP systems. In terms of evolution, modern data warehouses integrate with big data ecosystems, cloud solutions enable scalable and flexible architectures, Real-time processing capabilities enhance business agility, and data governance remains critical for enterprise success. Data warehouses are the backbone of enterprise analytics. If you like this video, hit that like button and don't forget to subscribe. Visit CodeLucky.com for more such useful content.